Hey guys, today we're going to be using the AnalogRead command with the Arduino to demonstrate how we can read analog data via a potentiometer here, process that data on the Arduino board, and then output to the servo based on the input from the potentiometer. And first of all, we're going to look at how exactly does a potentiometer work. And I'm not going to get real in depth. We're just going to go, over some basic theory here. I'll show you guys. Gives a rough idea. If you look at the potentiometer, you'll see we have the dial there, the control knob, and we also have 3 pins here. Okay, and how it works is you basically have the knob, which controls the wiper. Then you have resistive material going around the potentiometer, so it'll go around in like an arc, this resistive material. Okay, and this particular potentiometer is a 10K potentiometer, which means its maximum is 10 k ohms of resistance. The pin here, we'll just call it 0 volts. Excuse me. We'll call this, call it ground. So it may not be 0 volts. And then we'll call the other one 5 volts. So we're going to be feeding ground to this pin, 5 volts to this pin. And then the center pin is where the wiper is. And that is what you read with your Arduino, with one of your Arduino analog pins. Okay? And how that works is the wiper, basically when you turn that knob, it moves a wiper along this resistive material. And basically you're creating a resistor divider network here. So I'm going to move that up a little bit, and you're creating a resistor divider. And so whenever you're midway, you're going to be reading about 2.5 volts. Whenever you're here, you're going to be reading about 4 or so, and then whenever you're here, you're going to be reading the full 5 volts. And then the Arduino, on the Arduino side, once that, let's say 3 volts goes to the Arduino is going to translate that voltage into a number between 0 and 1023. Okay, so in the case of 3 volts, it would be, probably somewhere around 700 or so. That's an approximation. Then 5 volts, the full signal strength there would be 1023. 0 volts would be 0, and then anywhere in between would be a ratio there. But basically, whenever you're at mid-scale, you're going to see about 2.5 volts, and a little over 600 is going to be the number that's returned via the AnalogRead command on the Arduino. But we'll look at that in a little more detail. But that's our basic, that's the basic setup there. And it doesn't matter on these 3 pins here. These 2 outside pins, it doesn't matter. You can put ground or 5 volts to either one of these pins. The important pin is just to make sure that you get the Arduino analog input on the center pin there, because that's where this wiper blade is that we're going to actually be reading the voltage from. And if you want to know more about exactly how these work, I would suggest you look up information on resistor divider networks, and also just basic fundamentals of electricity, like path of least resistance, and figuring up resistance in a simple circuit, things like that. But let's go ahead and take a look then at a practical application of how we can use this. So we're going to go ahead and, first of all, we'll go ahead and plug our let's go ahead and start with the servo setup first because we're familiar with that. So I'm going to go ahead and take, this is going to be 4 AA, so approximately 6-volt battery pack, and I'm going to go ahead and put it right here. I'll put this voltage on this power rail here. I'll try and leave my hands out of the way somewhat this time. I found I've been covering the work a little bit. Okay, and then we're going to go ahead and bring the ground on over from the Arduino to this rail. So that'll tie those together. Then I have, of course, my servo with the 3 connections we looked at last time. And this particular one, the orange, we're going to send to, arbitrarily speaking, we'll just go to, let's go to 7. Okay. And then we have our power, which I just pulled out of there. So we've got our +5 here. Actually, this is going to be +6. And then we've got our ground here. Okay, so now our servo is all set up and connected there, and I'll go ahead and leave that there. Let's go ahead and make our connections then with the servo. And this is a 10 k-ohm servo. Potentiometer. And really it doesn't matter within reason. If you have 100 k-ohm potentiometer, that'll work fine. 85 k, really any potentiometer will work within reason. I haven't really tried up to a meg, but what happens is, because of the way this resistor divider network works out, it's looking at more of a ratio of the resistive material that it's passing through versus what it's not passing through. That's how it's getting that voltage drop there. So you're going to end up with a total of 5 volts anyways. So it's not real important what value you use. Now, different higher values can result in some issues with noise and things like that. So 10K is a good place to be, but if all you have is 100K, use it. It'll work fine. So we'll go ahead and hook our potentiometer up right here. And you'll notice on the Arduino, I'll go ahead and zoom in here, that some of the pins actually have A's on them down here, A0, A1, A2. That means those are analog inputs, which means that they have an analog to digital converter on them. So basically there will be a voltage coming in, and whenever you have those set up as analog pins, there will be a voltage coming in, and the analog to digital converter will then convert that voltage to a number between 0 and 1023. That's all that means. But only these pins here, A0 through A7, which gives us 8 of them, can be used for analog read. All the D pins are digital read and write only pins. And the A pins can be used for either digital read and write or analog read and write. So an analog write is kind of that's another subject we'll touch on another day, because it's not really truly an analog write there, but it is an analog read because of that digital to analog or analog to digital converter. So let's go ahead and hook up then to, arbitrarily we'll choose 5 just for fun. Doesn't really matter as long as it's one of those pins. And then we'll go ahead on the potentiometer, try and get a little better view here. There we go. Potentiometer, I'm going to connect the wiper just right there. think. Let's see. Yep, there we go. Yep, the wiper's going to be right there in the middle. And then we're going to bring the other two sides. We're going to bring plus 5 volts back out a little bit. Okay, I'm going to bring the 5 volts from the Arduino to one side. And I'm going to bring ground from the Arduino to the other side. Okay. So now what we have here is we have the servo connected to digital pin 7, I believe. Let me double check that, because my vision is terrible and I can actually see close up better with this camera than I can with my own eyeballs. Let's see here. Once it'll focus. There we go. Yeah, we are on 7 for the control lead for the servo right here. And then we've got our power and ground going to the outside pins of the potentiometer. And then we've got A5 going to the wiper of the potentiometer. So now let's go ahead and take a look then at the code and see how to actually use this input and convert it to a meaningful output. So let's go ahead and get our code started. And we know first of all the top that we are going to need to include servo.h here, the servo library, and I need to spell it correctly, I think. There we go. Okay, and then we're going to go ahead and declare our servo here, which is going to be servo, just call it servo 1. Servo 1 there. And of course every program needs a setup loop. And every program also needs the main loop here. So we'll go ahead and put that in now. Okay, so in our setup, we're going to go ahead and do servo1.attach, and that's going to be declaring which pin the servo is attached to. We said that's pin 7. Okay, and then we're going to go ahead and set up our other pin, which is going to be A5 as an input. So pin mode A5 input. That tells the Arduino to go ahead and turn on that analog to digital converter and be ready to read some voltages there. Okay, so kind of struggle through this thing a little bit. So the first thing we want to do is let's go ahead and we'll go ahead and make an integer variable called pot. Int pot equals, and then we're going to read, analog read A5. Okay, so whenever this command is run, it's going to create an integer variable named pot. Then it's going to assign the value of an analog read from pin A5. Okay, so we're going to get a value between 0 and 1023. Now, how do we actually use that value? Because we need a value between 0 and 180 for our servo. So there's a really cool command in Arduino that's called map that'll do just that for us. because it's something that needs to be done a lot. So we're going to use, let's see, we're going to make another variable. It's called int, and we'll call it mapped. There we go. Mapped equals, and then we're going to use the map command. And with map, you have to have 5 things. You have to have the source, which is going to be pot, that we're going to be working on. And then you're going to have the range of the sourced, the range of the input values there, which are going to be 0 to 1023. And then we're going to put in the range that we want on the output, which is going to be 0 to 180. And what that command is going to do, it's going to bring in, if it brings in a value of 1023, it's going to assign it the value of 180 to this variable we've created here. And then of course, in relation, if you have 600 or so come in, it's going to put 90 to this mapped value here, and it's going to give us some figures that we can actually use to send to our servo. So now that we've done that, we're going to go ahead and send it to our servo. So we're going to do servo1.write, and we just have to send that mapped number there. Okay. And I've already played around. This servo is a little sketchy on the outside number, so I'm going to back it off a little bit. Okay, so we're going to have it a range of 4 to 176 instead of 0 to 180. It can't actually get to 0 and 180. It starts doing this weird thing. And I'll show you the difference here in just a moment. Go ahead and upload the code now, and we'll take a look at what it does. I'll verify first. Okay, we've got a problem here. Void setup. Function definition does not declare parameters. What am I doing wrong? Oh, excuse me. I did the same thing with loop. Alright, here we go. Try again. There we go. Alright, let's go ahead and upload this thing. You see the program uploading because it's flashing there. And this will usually indicate shaking servo. Oh, it looks like the control pin wasn't going in well. Okay, let's go ahead and put this back in. There we go. It's not making very good contact. I actually have, these are not really set up good for a breadboard, these little pins. I actually have another, show you guys this little thing I came up with. This is another little potentiometer. I actually made this up last night. I put it on a little piece of perf board, and I just put some nice header pins down on the bottom there. I only needed 3 of the header pins, but I put 3 more just to make it a little more stable. And I think you'll see a big difference here. Let me move these. Okay, there we go. Quit freaking out on us. And now you can see I rotate fully counterclockwise. Now I'm going to rotate clockwise. And there we go. We have control of that servo now. And that's about all there is to it. Now you could also use AnalogRead. Once you have that value in there, you can use it to control like how many LEDs are lit up, or the rate of a flashing of something, or the brightness of a screen, or anything you can imagine. You can use that AnalogRead to actually use for your output there. And of course, you can read up things other than a potentiometer. Maybe you want to read just a voltage, or maybe you want to read some other type of sensor, a temperature sensor or something like that. It could be used for a great number of different sensors. It's pretty much unlimited. But that is AnalogRead, and we will look at some more commands and more devices hopefully next time. Thanks for watching. Bye-bye.